Hello, and welcome to this demo of the XMS AppSync integration, which provides VMware-level visibility directly from the XtremIO management server. As part of the setup, the first thing that needs to happen is we need to point the XMS to an existing AppSync server. We do this by clicking the Gear tab and selecting AppSync. Now let's actually add the AppSync server to the XMS. Now this integration works in both a brownfield and a greenfield deployment, where in the case of a brownfield deployment that you've already deployed the AppSync server and already registered VMware objects to it, it will just go ahead and suck all that information in. So I'm going to go ahead and add my AppSync server, and then I'm going to give it AppSync administrator username and credentials in order to go ahead and actually create this link between the XMS and the AppSync server. Now what's happening in the background is the XMS is actually going ahead and it's creating a brand new user in the AppSync server, and it's also registering all the different XtremIO clusters that are part of this XMS directly to the AppSync server. And this is exactly what you'll see here. Under the AppSync server settings tab, if I click storage infrastructure, you'll notice that it has gone ahead and has automatically added the XtremIO clusters that are part of that XMS to the AppSync server. It has also gone ahead and created a brand new user in the AppSync server, which is actually just the XMS. Next, we have to go ahead and actually register it to a vCenter server. As I mentioned before, this will work in both a greenfield and brownfield deployment, where in a brownfield deployment, if a vCenter server is already registered to AppSync, it will just go ahead and suck that information in. In this case, it's a greenfield deployment, so I'm going to go ahead and point it to my vCenter server. Once added, you'll notice that the last discovery time is blank because it hasn't actually gone ahead and discovered all the different data stores and virtual machines. So now by clicking the AppSync tab on the left pane, I can go ahead and actually click Discover to go tell it to discover all the different VMware objects that are registered to this vCenter. The XMS has intelligence built into it in which will only display back VMware data stores that reside on any of the XtremIO LUNs that this XMS is managing. So rather than displaying all the data stores that belong to an entire vCenter data center, it would only show back the ones that belong to these particular XtremIO clusters that belong to this XMS. From this, you now have basic information such as the name of the data store, the name of the volume the data store actually resides on from an XtremIO perspective, the vCenter server, the size of the VMFS data store, the type of the data store, and the different ESX servers that it is currently mounted to. Another place you can see this relationship is in a screen you're probably more familiar with, which is the existing Volumes Configuration tab. By going to the Volumes Configuration tab and going all the way to the right, you'll see the Show More column, which you can click and then scroll down to the bottom and select Data Store. With this, you'll now be able to directly see from this one view the relationship between a data store name and a volume name. This allows the administrators to see the relationship between a data store and a volume all from one screen. Going back to the AppSync tab, you'll notice that before we were able to see a list of data stores that reside on this XtremIO array. However, the virtual machines tab is showing as blank. That's because in order for it to show the VMs, we need to go ahead and actually discover and protect a data store. In order to do so, we need to tie a data store to a service plan. I'm going to go ahead and create a brand new service plan. After giving the service plan a name, I need to define the service plan as running on a specific interval schedule, or if it needs to run on demand, meaning running only when I tell it to run. Next, I need to also define whether the service plan should take application consistent snapshots leveraging VMware APIs, or simply crash consistent snapshots using XtremIO virtual copies. In the next screen, I also have some other parameters that I can define, such as being able to mount a data store copy when it's running it to these discovered ESX hosts, But for this particular example, I'm just going to let it create the application consistent data store copy without actually mounting it. And at the end, I can see a nice summary of what the service plan does, and I'm going to click Apply in order to go ahead and create the service plan. Looking at the Service Plan tab, I can now see that the service plan that I created is now available with the schedule of on demand. And what I need to do next is actually tie a data store to this service plan. I'm going to go and select my data store called Virtual Machines, and I'm going to go ahead and subscribe it to the service plan that I just created, which is this one. And by clicking Apply, I've now tied this specific data store to the service plan that I previously defined. Since the service plan that this data store is subscribed to is an on-demand service plan, I now actually need to go ahead and tell the service plan to go ahead and run. So I'm going to go ahead and click Protect on the data store and click Run Now, specifying which of the service plans to go ahead and run. By clicking Apply, the XMS is now working with AppSync in order to orchestrate the entire copy process in an application-consistent manner, calling both VMware APIs and XtremIO APIs in order to do so. If I go to the vCenter UI, I can actually go ahead and take a look at what's happening under the covers, which again is the whole orchestration process in order to make these VMware consistent copies. Now that the copy process is complete, I can see the point in time for this data store object listed as a recoverable or mountable point in time with some basic information such as the creation time, the volume that it resides in, the snapshot sets that it resides in, and etc. Also, as I was mentioning before, now that it's gone ahead and actually discovered and protected the data store, we can now see the VMs that are associated with any of the data stores that the integration has gone ahead and protected. Another place where I can see this is, just as I was showing before, is in the existing volumes configuration tab. You can, by clicking on the volume, you'll see under related entities, you'll see a virtual machines tab, and by clicking it, you'll see all the virtual machines that reside in this volume. After protecting the data store, there's a couple of different options available to us of what we can do with the different point-in-time copies. The first is selecting one of the point-in-times and simply mounting it as an additional copy. So, for example, in the test dev use case, I simply select the data store copy and I click Mount, specifying the ESX host for which to mount to. Alternatively, I can also restore the entire data store. By going to the data store and selecting Restore, I'm presenting with the different point-in-times from which to restore from, along with some additional options that I can select, such as powering down all the VMs before performing the restore, which is highly recommended, and then whether I want to register and power up all the virtual machines once the restore of the entire data store is complete. But for the purpose of this demo, I actually want to show restoring an individual VM. So let's say this particular virtual machine, SQL VM server, happened to either get corrupt or got deleted and needs to be restored. So I'm actually going to go ahead and go to my vSphere and delete this VM. And then I'm going to go back to the XMS and begin the VM restore process. So I'm going to click the virtual machine, click Restore, which is then going to present me with different point-in-time copies that are available for me to restore from. So I'm going to pick this particular copy, click Next, and then there's a couple of different options which can be selected, whether to restore to the original data store location, or if I want to restore it to a different location, either a different vCenter server, different data store, or different ESX host. I'm just going to select restoring to the original copy location of where this VM resided, and then I'm also going to specify which ESX host this VM to attach to, and then I'm going to click Next, where I'm presented with a warning screen showing me exactly what's going to happen, which is restoring this virtual machine called SQL VM server to its original location. I click apply, and the process begins. Now, because this is a process that orchestrates a bunch of different steps, just give it some time. It's going to take a little bit, and I'm going to show you here by clicking the vSphere tab. You'll be able to see actually a lot of the stuff that it's doing under the covers. Going back to the XMS, we'll get a confirmation that the restore process was complete. And by going again to the vSphere web client, we can actually see that this VM exists again. And I can just go ahead and power it back up. As you can see, what this integration provides is VMware level visibility to XtremIO, allowing administrators to view and protect VMware objects directly from the XMS. I hope you enjoyed this demo. Thanks.